Okay, yesterday we already talking about the diode. Diode that means the rectification device. Rectification that means they converting AC to the DC circuit. Okay, and now we continue on the number 2. They given the diode, that's a silicon diode, 0.7 volt. First question is, diode on or off?
Off.
So just let me know for the number 2. The diode is on or off?
Off.
Okay, diode will be off. Now, telling me how the diode be off.
It's different from the one above. The one we did yesterday was forward bias. This one's flipped around, so it's reverse bias.
No, that is not.
So, BA minus BC will be 0 minus 5.
Okay, first thing, if you want to telling the diode on or off, then you're supposed to know what the voltage is the positive of the diode. Okay, and what the voltage at the negative. So easy to recognize positive diode is 0. The question is what the negative voltage here?
5 volts.
5 volt.
Yes.
Okay. The reason how do we know that the 5 volt?
Remove the diode.
Yeah, you get it. So in order to decide diode on or off, you need to know both sides of the diode to see what voltage. Okay. In order to know what voltage at the VO here, and the first thing you're supposed to remove this diode. Okay. When you remove the diode, that means you get an open here, and you get a 5 volt here. That means you can get VO 5 volt. So 0 here and 5 volt on this side. The diode will be off. That's correct. What VO? What is the VO?
Of 5 volts.
5 volt.
5 volts.
You understand the diode is off, that means you open here. That will be open. No current will be flowing. So VO will be 5 volt. What the current?
0.
0. Perfect. What the voltage across the resistor?
0.
Yeah, the guy get better. Okay, any question on number 2? Okay, number 3. Diode on or off.
Off.
The diode, let me see, plus here. It's off because on one side you have a 5-volt supply, on the other side you have an 8-volt supply.
You get it now, Mr. Smith.
So in the 8-volt supply, the cathode is more positive than the anode. And for these diodes, we want the anode to be more positive for the diode to be on. And that is not the case. So I would say it's off.
Okay, they off. Go to 9.
Zero.
0.
Yeah,
The thing is the diode off, they will be open.
open.
Okay, so no current flowing.
Hey, Mr. Pham, could I ask a question?
Yeah, go ahead.
I'm sorry, I forgot this, but like typically in these, I know you did, I don't want to get into it. I'm just asking a question. Typically you deal with like Norton and superposition and all that stuff. When you have these two supplies like that with the diode, what else do you do to find out about this circuit?
Now, the first thing you have to decide diode on or off first
Right,
before you can do anything.
right.
So now you will say diode will be off. Off means they open from here to here. Okay,
Right.
so they're open. That means you get no current.
What if the diode was flipped around the other way in the exact same circuit?
You mean for the diode, flip it,
Yeah, and it's in the same circuit.
then the diode will be on. Okay. If you flip the diode, that means one side positive 8 volt, the other side 5 volt. So the diode will be on. Okay, now number 4.
It's on.
You say the diode will be on, right? Forward bias.
Yes.
The thing that you can see on the diode, positive connect to ground, 0 volt. Okay. And the negative connect to the minus 100 volt. So the diode will be on. Okay, so the answer will be forward bias. Okay, that means we go to the next one. But before we go to the next one, okay, let's see, I want to ask you a few questions.
I got a question. So if the diode is facing down, that means it's off, or if the diode is facing up, that means it's on?
Right.
Got it. Thank you.
Okay, now I get the question here. Not cathode on or off. Okay, first one on or off.
Off.
Oh,
They could be off easy, right?
right.
The thing is VD. That means the voltage across the diode. VD, VA minus VC.
So that means it's a 0 minus
0 minus 2 volt
minus 2 volt.
equal minus 2 volt.
Mhm.
Less than,
One sec.
so they will be off.
Mhm.
What I'm saying is, when you're working with a diode, if you don't know they on or off, you cannot do anything. Okay, second one.
On.
Mr. Pham, I have a question.
Go ahead.
Yes, hi. In this example you're giving, the diode is facing, or it's aiming to the right, and that's considered off. So if it faces the left, does that mean it's on?
Okay. If you want to know they on or off, you have to calculate the VD.
Okay.
VD, that means the voltage difference between voltage at anode and the voltage at the cathode. VA, you connect to the ground, so 0. VC, you connect 2 volts, so 0 minus 2 volt, you get minus 2 volt. Minus 2 volt is less than 0.7 volt for silicon diode, so they must be off. The diode for silicon VD have to be greater than or equal 0.7 volt, or sometimes 0.65 volt. That's okay. That's how
Okay.
can we telling on or off. Yeah, go ahead.
Yeah, I think it would be simpler if we, at the power supply, connect to ground on the other side. That would be more, I think, like -2, other side connect to ground. That way we know that the +2 will go to ground. I might be wrong. I don't know.
You're talking about first or second problem.
The second.
Okay, the second. Now telling me on or off.
On.
On. What I'm saying again, you must be calculate the VD. That is VD. VD, VA minus VC. 0 minus 2. So
That's
VA
+2, yeah.
greater than
Yeah, I got it. Thanks.
Yeah. Okay, so in order to telling the people, telling diode on or off, you must calculate the VD. That means the diode voltage from anode to the cathode. If they greater than or equal 0.7 volt for silicon, then you say diode on. If they greater than or equal 0.3 volt for germanium, then the diode will be on. That is trying to make it clear for your guy. You cannot see the circuitry and say on or off. You have to do your calculation. Okay, you already see this circuitry. And you know the diode will be on, right?
Uh.
Okay. Now, after you say the diode will on, then the circuitry not look like it anymore. They will be look like that one.
Battery.
Okay. That means after you know the diode will be on, then the diode can be substituted by the battery. And the value 0.7 volt. This side positive. Okay. This side positive. This side negative. That is a very, very basic thing. Everyone have to know. The thing is, after we know the diode on, we not deal with this circuit anymore. We have to deal with this circuit. Okay, any question? Okay, so that's why I just bring it up some case I know for sure the student maybe still confusing. Okay. In order to know diode on or off, you need to calculate the VD. If the VD higher than equal 0.7 volt, then you say diode off. Less than that, the diode will be off.
And in this case, Mr. Pham, in this case, we had 5 volts minus 0 volts, which is equal to 5 volts. And 5 volts is greater than 0.7, correct?
Yeah,
Okay, and then the one on the right, you replaced them with batteries. So do you add those up or you subtract them?
that means you say you get a 0.7 volt here.
Right,
You get 5 volt here.
right.
So the current flowing from 5 to 0.7.
Mhm.
You can calculate the current I.
So you go 5 minus 0.7.
Exactly.
Okay, thank you.
However, I bring it up here. Just make sure you understand it. After you know the diode on, you're not using this circuit.
Right,
You have
right,
to
right,
send it to this circuitry.
right, right, right,
Substitute the diode by the battery.
right.
But that resistor is really sensitive to allow 0.7 volts to go to the diode. So even if voltage was 1 volt, that resistor is going to limit a lot of the voltage that's going to go to that diode. So that resistor has a lot to do with its tolerance before that diode is going to even be open, right, Mr. Fan?
Yeah, but the thing is that's not a technician job. You are engineering.
But still, that even if it was out of tolerance, that diode is,
Yeah, the thing is you not design any circuitry. So don't worry about that thing. We just test it. Okay, now next one. Another what we call a ZENER diode. First thing they given to you, this is a symbol for the ZENER diode. You see the difference. This is an anode and this will be a cathode. Okay. Now, basically, they want to keep a certain voltage. They need to using the ZENER. When they break it down, okay. Now you can see this one is the ZENER symbol, and basically will be converting to the battery, and positive here, negative here. Okay, and normal diode. Okay, normal diode, that means positive on this side and negative on this side, and value 0.7 volt for silicon diode. Okay, a major application for ZENER diode is a type of voltage regulator for providing stable reference voltage for you in power supply, voltmeter, or other instrument. That will be normally using in the power supply. For example, for power supply, you can get 5 volt, 12 volt, minus 12 volt, or minus 5 volt. So basically, they don't want any more voltage higher than that voltage. So that's why they need to using the ZENER diode. And also you understand in the digital circuitry, using only 5 volt. Any voltage higher than 5 volt can cook the IC. So that's why they need the ZENER. Set it, make sure no matter what input coming in, and the ZENER will keep it at 5 volt only. So now you understand the purpose of the ZENER diode. And also try to remember when they break down, then ZENER can be substituted by this battery. Otherwise, if they're working normal, that means same thing like we already did it. Okay. Now, they given you this circuitry, 20 volt, and you can vary any voltage you want. 220 ohm, and the ZENER, we given to you 10 volt breakdown. So basically, you can get VG equal 10 volt. Okay. Now, when you go to the electronics store, you're asking for ZENER diode. You want to buy a ZENER diode. First thing they will be asking you what voltage you want. Otherwise, they don't know which one. Is it you want a 5 volt ZENER, 10 volt ZENER, or more, or whatever voltage, but you have to identify the voltage. Okay. Now, for the circuit show, they given you VG equal 10 volt. What if V out? If V in equal 20 volt.
10 volts.
What V out?
10 volts.
10 volt. Who else? Okay.
10 volts because the power supply is 20.
Okay. How come we know V out equal 10 volt?
The limit of the ZENER diode is 10 volts.
I understand you say a limit, but it's not quite clear for my question. How do we know it's a 10 volt?
You have to take the, like you said before, take the diode out and then work it like we did the other one.
Exactly. That's what I wanted. In order to know what the V out, first thing you're supposed to be not the ZENER here. And that will be telling you output here will be 20 volt. You right?
Right.
Now, if they are 20 volt and the ZENER breakdown 10 volt, so
20 minus
ZENER
10.
will be breakdown.
Mhm.
Open.
Oh.
Open circuit.
Now they be breakdown. Why? The thing AV out 20, higher than 10. So that's why we break it out. And V out now will be equal 10 volt.
It'll equal whatever the ZENER diode is rated for.
Yeah, equal the ZENER breakdown voltage.
Mhm.
So the
I'm
answer
sorry.
A will be 10 volt.
Excuse me, Mr. Pham, can you explain that again, please? About and
Okay, now I try to repeat it. First thing, you must know what voltage at this point without the ZENER. Okay? So that means the ZENER open. Then you know voltage here will be 20. Okay? So if they equal 20, that means they greater than 10. Okay? Then now the ZENER will be breakdown. That means no matter what voltage higher than 10, output must be equal to 10 volt. That is the purpose for ZENER diode. You want output to be 10 volt. no matter what input higher than 10 volt. So, number A, Vout equal 10 volt. Okay, now I want to change something here. Okay, I change the voltage here, not 20. What Vout?
0.7,
What Vout equal?
0.7 volts.
You said 27 volt. Who else?
0.7, sir. Mr. Pa.
You said 0.7.
Yeah, in this case, the source voltage is smaller than what the Zener is rated for. Yeah, so I would say it's 0.7 because it's going to operate like a regular diode.
Okay, now. Is it a Zener breakdown or not?
No, it's not in breakdown.
Not in breakdown. How?
Okay, you take the Zener diode out. So then you have 5 volts up top. And you have 0 down the bottom. So it's not in breakdown.
What Vout?
Then let me see, you got 0.
You're telling me.
Trying to do it the way he said it. Take the diode out. This becomes 5.
Even you guys already know that from last semester.
5.
But what I want to really understand it. Again, on this circuitry, I change 20 volt to 5 volt. I want to know what the Vout.
Five volts.
5
5
volts.
volt.
5 volts, yeah.
Okay, now, first thing, we have to look like we have a no Zener here.
Right,
Okay,
right.
what we want here?
It's 5 volts.
5 volt. Okay,
Because if the Zener is not in breakdown, then it's treated like a regular diode, correct?
exactly. So they 5 volt. Basically, they break down if they higher than 10. Okay, 5 volt is not higher than 10. So the Zener working like normal diode.
That's right.
Okay, that means you get positive here, you get negative here. Okay, so this diode will be on or off?
Off.
Diode will be off. That means Vout will be equal 5 volt.
I'm kind of lost. What are the stuff that I have to use to be able to get that 5 volts?
That means diode off, they open. And now you can get only 5 volt here, register here, and output here open. That's what we already did it. No current flowing.
Hey, Mr. Pham, on this one here, you still use that formula, VD equal VA minus VC?
No, you don't have. You still try to say easy to recognize. One side diode is 0 volt, the other side 5 volt.
Oh, okay.
Don't have to do calculation.
Mhm.
Recognize right away. Negative more than positive. Diode have to be open.
Because 5 is higher than 0, and since it's treated like a regular diode, the anode side is like 0, and the cathode side is like 5. So then that's why it would be reverse bias or open. Is that correct?
Correct.
All right, thank you.
Only thing the voltage higher than 10. Then they break down no matter what voltage, 20 volt, 30 volt or more, they cut it down. Only 10. That's why they break it down. We're already telling you. ZENER can be break down or just working like normal diode. Okay.
I have a question.
Yeah.
I heard someone said it would be treated like a normal diode. So in what scenario? So what about the scenario would make this diode be treated like a normal diode?
Yeah. You see that? They break down. Then you substitute ZENER by that breakdown voltage. Positive on this side, negative on the other side. However, if they not break down, they go to normal. Okay, and positive on this side and a negative on the other side. And the value will be 0.7 for silicon. And now, when we go into this circuitry here, we know this is a 5 volt. 5 volt is less than 10, so they not break it down. If they not break it down, they have to be working like normal diode.
I got it. Thank you.
You're welcome. Yeah, any question, any confusion, just bring it up. Okay. I try to help you guys really understand electronics, not for technician only, but also for your future. If you keep real going higher and higher. Any confusion, anything you don't know, just bring it up. Okay. Number B. What is the current through 220 ohm?
0.
What is current? So how come you said 0?
It's an open circuit.
Now, you know, in this case, ZENER breakdown, right? This is a 20 volt. So ZENER breakdown. Breakdown, so the
10 volt.
voltage here will be
10 volt.
10 volt.
10 volts.
10 minus.
Now you
10.
get a 20 volt on this side and a 10 volt on the other side. So the current I will be equal 20.
Minus.
220. Okay. Okay, any question on that current I?
45 milliamps.
Yeah, I don't care. Your guy job, not me. That's a Mr. Smith given. Okay,
So, Mr. Pham, I don't mean to beat a dead horse to death, but the main thing with these diodes is to take the diode out of the circuit and see what you have first, correct?
exactly.
All right,
In order to decide they on, they off,
all
they
right,
break down or not break down.
okay.
That is the key point. I hope the guy can follow it. Okay, now they change the power supply to minus 5 volt. So they change that to be minus 5 volt. What the V out?
Be 0.7.
V out equal what? Repeat.
0.7.
If I change the power supply to minus 5 volt, my question is what V out equal?
Move.
It's
5
not
volt.
it's not in breakdown. Well, let me see. Right, it's not in breakdown, so it's got to be treated like a normal diode.
Then what? I asking for V out.
0.7.
Okay. Now, without the ZENER, you know to get minus 5 here. Correct?
Right.
That not breakdown.
Oh, it's forward bias. I get it. So it's forward bias. So it's got to be the V out has got to be like 0.7 because the ground is 0 and 0 minus 0 is greater than minus 5. So that means that the diode is on. Diode on.
Correct?
Mm-hmm. And then you do the VD equals VA minus VC formula, and that tells you whether if it's
Now, what I'm saying is, when you know the diode on or off, you're no longer using that circuit.
oh, okay.
Then you have to get the other circuitry. They will be look like my note here, register here, and now you can get the diode here. Okay, negative.
And
positive
Right.
minus 5 minus positive 0.7
7.
volt. What VL equal?
0.7.
Negative 0.7.
Yeah,
Exactly.
negative 0.7.
Have to get negative.
Mhm.
The thing is, it's a negative right here.
Right.
When you decide diode on or off, you must be substitute diode by the battery or open circuitry. If they off, if they on, substitute by battery, which side will be positive, which side will be negative.
Mr. Pham,
Yeah,
I still don't get how you got to negative 0.7. Is it because it's negative 5 volt, then it becomes negative 7 on the V out?
okay, now. My question now. Tell me the diode in this case on or off.
Off.
How come you say off? 0 volt here, minus volt here.
Hey, Mr. Pham, can you put a 0 there so we can actually see that, just to make sense out of it? By the ground. Yeah, yeah, that's 0 volts. Yeah.
If you want to calculate the VD equal 0 volt minus to minus, right?
Right, minus 5.
Greater than 0.7,
Right,
they are.
right. That's what I wanted to see, yeah.
And is VD, is it always going to be VD equals 0 volt? The equation?
Ground? You mean talking about that guy, right?
Right. So it's always 0 volt.
They must be 0 volt all the time. Common.
And the key thing here, Mr. Pham, the 0 is on the anode side. And the minus 5 is on the cathode side. And 0 on the number line, 0 is greater than a negative number. So that's why you got what you got.
Okay, now look into ZENER right here. We're already telling you right here.
Right.
This side positive, this side negative.
Right.
Okay. So when you say that ZENER, they're working like a normal. So that's why this side have to be positive.
Right.
The other side have to be negative.
Right.
The value 0.7. So
Right.
that's why you get minus 0.7.
Mhm.
Okay. Golden eye. Minus 0.7 minus to minus 5 divide 220. That means you take the voltage difference between V out and input divide by resistor. So you get 4.3.
19.5 milliamps.
The thing is, you understand is the current never negative. Okay? They have to be positive.
So by being positive, because it was 0.0195, I have to turn it into 19.54.
What you say for the input positive or what?
Yeah, so I did the 4.3 divided by 220 equals 0.
How come you get 4.3?
Because it was minus 0.7 minus 5.
Minus 0.7, minus to minus 5, you get 4.3.
Yes,
And you divide by the zeta.
correct.
The answer Mr. Smith gave it to me 19.5.
Because a minus times a minus is a plus, so the 5 is really a plus. And then you got minus 0.7. So 5 minus 0.7, whatever that is, you divide it by 220, and that's what I get. So 5 minus 0.7 equal 4.3, divide 220 equal, and I get 19.5 milliamps.
Correct.
So do you have to flip the from 220 being under on the bottom, you have to flip it to being to the top?
I'm sorry, can I just butt in? I think I understand what he's saying, because when I do it on the calculator, I understand the negative is positive. So, you know, negative 0.7 plus 5, but it's like when I do it on the calculator, it's 0.01954554, and then it goes that long number. So it's like, how do you get 19.5 milliamps? I mean, I guess on your calculator, and then on my calculator is 0.019545545.
That's
What you do-
ampere. You have to converting, if you want, to milliamp. Time 1,000.
The 5 is inside the parentheses. So you're multiplying a negative times a negative. And if you remember for your math from algebra, a minus times a minus is a plus, which means the 5 is really a plus 5. So you're subtracting minus 0.7 from plus 5. And then you'll get a plus 4.3, and then you divide it by 220. In your calculator, you could just put it in. You could put in minus 0.7, and then minus, and then in parentheses, put minus 5, and then get that answer, and then divide it by 220, and you'll get the 19.5 as well. Exactly, Mr. Vam. Yeah, the 5 is a plus. Now it's 4.3 divided by 220.
Yeah, so I did get that, but because if I do the 220 divided by 4.3, it's 50.
No, it's 4.3 divided by 220.
I think they're not understanding that the answer that we get is an ampere, and you have to convert to milliamps.
Yes, that's
get
what I was saying.
the
Yes,
19.5.
yes, yeah, exactly. Yeah.
Actually, when you divide 4.3 by 220, your answer on the calculator will come out to 0.0195 and so forth. And then you have to move the decimal point 3 places to get milliamps.
Correct. That's what I was trying to find out. If you had him, like I said, you have to move the decimal point 3 times to be able to get your answer.
Yeah. Once you divide the 4.3 by 220, you'll get 0.01954, so forth. And then you move the decimal point to the right 3 places, and that's where you get 19.5. But then you got to write down milliamps.
Hey, Joe, before you do division, before you do the 220, don't you have to get the numerical value of the upper 4.3 before you do the division of 220?
No, just like Mr. Pham got it there. What he showed you down the bottom was you got minus 0.7 minus a -5 in parentheses. The -5 in parentheses, like in algebra, minus times minus is a plus.
Right, what I'm saying is the 0.7 plus 5 divided, it gets you 4.3, right?
Correct. And then you divide the 4.3 by the 220, because that's Ohm's law. That's V over V, current is equal to voltage over resistance.
But before I can even divide 220, I have to do it equal on the 4.3, and then I equal that, and then I divide 220, and then I get my 19.5. If you don't do your 0.75 and then equals to get the 4.3, you'll get a totally different number.
If you divide 4.3 by 220, you'll get a small number, but you got to move the decimal point 3 places.
Yeah, convert to milliamps.
And convert to milliamps.
No, I understand you do the 4.3 220, you get the 19, right? But what I'm saying is,
hey, Lowell, look here, he's doing it right now.
because when I was doing my calculator, 0.7 minus brackets minus 5, I have to equal that first before I do division 220.
Is it 9.5? No.
You see that 4.3 divided to 20. Ohm law, you get ampere, 0.0195.
Yeah, 19, yes.
Now, if you want the milli times 1000,
19.5.
then you get 19.5.
And 4.3 is minus, I think.
4.3 is plus.
Your schematic is minus.
Now, in the formula, you got minus 0.7 minus a -5. The minus in the middle means you multiply that minus times the minus inside the parentheses, which makes it a plus.
Right, you just switch. You start with 5, and then you go -7, -7. -5, -7, -7.
No, -5 minus 0.7.
You start from the left and go to the right.
Okay, now, if you're looking into this circuitry, the current will be going right to left or left to right. If you're looking on this circuitry, telling me the current will be going from V out to V in or V in to V out.
Well, it's negative, so it's V out to V in, right? Because you said it's a negative 0.7.
Is it the current go this way?
I would say, yeah, but I could be wrong.
Why?
It's you got negative 0.7.
The region A minus 0.7 volt greater than -5. So that's why current have to be flowing on that way.
Yeah, oh, I see what you're saying.
Current have to be flowing from a higher potential to a lower potential. So that's why,
Yeah, minus 0.7 is the high potential and minus 5 is the low potential.
Ohm's law telling you I equal V out minus V in divide 220. And V out is minus 0.7.
Right.
Minus to minus V in equal 5. So that's why you get 4.3. If you don't know, now you have to learn that. You understand that a technician will be more skilled job, get paid more. So that's a really, you have to understand. I've been teaching for too many years, and I understand the student. Only thing is some students have to be working a little harder. Okay, any question on this problem?
I'm sorry, one question. Why do you convert from amp to milliamp? Is it because you need a number?
That normally they're using milliamp. They don't want amp.
Mr. Pham, I can
Yeah.
help you there. I researched that when electricity was being discovered, say 200 years ago, people were working with it. They used amps, but then they discovered it was too high of a unit to use. So they had to get a smaller unit. So they started using milliamps. It would be like if we started using for our weight a ton, my weight would be 0.19 tons. So we would have to scale it down to a pound, and that would make more sense. So that's the reason why.
Okay. Anytime you get the value, voltage, ampere, and also you understand how to convert into millivolt or milliamp, microvolt or microamp. Okay, depending on what they ask for. Normally, they're asking for the value in this case will be milliamp. Then you cannot using 0.0195. You have to multiply by 1,000 to convert it. Normally, we have to deal with that. Okay. Ampere, milliampere, microampere. Okay. You're supposed to know how to convert it.
That was the purpose of the scientific notation in the homework, correct?
Right. 10 power of 3, 10 power of 6, or minus 3, minus 6. Try to get along with that. Okay, now on this problem here, you get 24 volt and you get 470 ohm, and the load will be 490 ohm. For the circuit shown for no load RL. That means the first thing they support to be no loading, not on this one. Take that out. And they want to know IL. What IL supposed to be? That means they remove RL. And they want the current going to the VL.
Mr. Pham, I'm just asking, would you attack this the same way you did the other one? Okay, you said without RL, but then take out the diode and then see what you have first. So then when you measure, you'd have 24 on top, and 24 is bigger than 12. So then the diode is not in breakdown.
But you don't have to do. In this case, when they remove RL, they're asking the current go to RL. What IL equal? They remove, that means open.
Yeah.
What IL equal?
0.
0. Correct. The thing is open circuit. No current can be flowing there. Okay, you get that?
I just have a quick question on that. How do
Yeah,
we
go
know
ahead.
that RL is open? Or that section of the circuit's open?
Open at the output. So if they open, the current cannot flow in to the output.
How do you know that it's open like in the first place?
No,
I
no, that's
understand
what
that
they
it can't
said.
flow.
They said for no load. That means
Oh, okay.
open.
Okay, okay. Thank you.
You're welcome. Okay, now, next one. Now, for this circuitry here, they want to calculate the current IG, ZENER diode. IG. Okay, now, again, when you deal with the ZENER, they can be breakdown, or they can be working like normal diode. In order to know, then first thing, you must be remove ZENER and calculate the V out to see what V out here equal. Okay, so that's what I say, no ZENER. What V out equal?
24.
How do we get V out?
You measure from ground to where that black dot is at.
Now you have to do your calculation. I said, in the case no Zener diode, I want to know what V out. Who telling me? You understand?
Should we not find the voltage drop, find the current for some of the two resistors, 470, 490?
We're not
Use
trying
that.
to find any voltage drop. My question is, you get the circuitry here, resistor here and resistor load here. I want to know what the V out.
24 volts.
Voltage divider.
Exactly. That's what you have to know. You get your resistor RRL. And now you want to calculate the V out. So V out have to be equal 24 volt times RL divide R plus RL. I put in here to make sure you understand. Voltage divider. Okay, so what V out equal? Who do calculation tell me what the value?
12 volt.
How many volt?
12 if we have the voltage divider.
It's 12.25.
I got 12.25 also.
$12.25. Okay. First thing you must know what the voltage without Zener. In this case, we calculate, we get 12.25. Okay. So Zener breakdown is 12 volt. So the Zener will be breakdown or normal.
Breakdown.
Breakdown. The thing is they higher than 12 volt. So that's what I said. Zener breakdown. So V out equal
12.
12 volt. 12 volts.
12 volt. You get that?
Yeah, so you have to.
Okay, what VL equal 12 volt. Now they want to calculate the IG, Zener diode current. So first thing you need to calculate the I total. You understand right here, you get 12. So I total equal 24 minus 12 divide 470. You get 25.5 milliamp. I just converting to milliamp.
Yep, 25.5.
You get that?
Yep,
Okay, now you see the I total go up until this point. One going down, IG, another one go IL. So you need to know IL. IL. VL. IL. $24.49.
yep,
Milliamp. So IG equal I total. IL. And that 25.5 they will be 1.01. You get that? So that's all already solving for number C, number D, number E. Okay, so basically you have to go through again. Get along with the way we're working with the diode and the Zener diode. The thing is that a very simple circuitry. Easy they asking you when you get job interview. You don't have to do calculation, but they want to know. For example, in this example, they want to know the Zener breakdown or not. And you have to explain. Okay, so technician one tomorrow will be on the other Zoom. They will be try to help you to install the C++ software. That's what we will be using in the program. And also another day will be teaching you how to working on the left phone. I hope after next week, we're able to go back to the lab for your guys to working on. Okay, up to this point, any question?
Yes, so for the IT, sorry, I got 23.97. How did you guys get 25.5 MA?
You see, I calculate IT 24 minus 12, divide 470. Only thing is you just using your calculator to get to see if you get 25.5 or not.
So I just need to get to 25. If it gets to 25,
I said you take 24 minus 12, divide to 470, that will be ampere, you convert into the milliamp. Try to work over and over on the time. You got ampere, you want to get to the milliamp time 1,000.
yeah, I'm still lost. I don't get it.
Hello, Mr. Sam.
Yes, Mr. Pham.
You ready for the quiz number 2?
Yes, sir.
Okay, now I stop my share and you guys take the quiz number
2.
2.
Okay, so just make sure you download that. Make sure you download the answer sheet from the website, please. Okay, so let me go share. Okay, so make sure you go to the website and just go to the handout and make sure you're download the DC quiz 02 spring 2022 report. Okay, make sure you download that, and that is the answer sheet that you're going to put the answer on. And you're going to be uploading this quiz after you complete it onto the website. Okay, so make sure you make sure you upload in the right place. Okay, you guys are Tech 1, section 1. So when you upload here, make sure not to put this tick box. When you put a tick box, that means it's for Tech section 2. That is only for student in Tech 2. Okay. So we got people that keep on turning in the wrong place, and it's hard for me to find you guys, everyone, because there's a whole bunch of students. Okay, so make sure you upload it. Just don't put a check mark. This one only for Tech 2, student only. Okay, so all right, so here we go. All right, so we're gonna be running the slideshow. Okay, so here we go. Okay. Okay, so that's pretty much it. So make sure you upload the answer sheet to the website for me. Make sure you upload in the right place. Okay, so if you keep on uploading the wrong place, we'll have to give you 0 for not following the instruction. Okay. Okay, so stop sharing. Okay, let me see in chat real quick, see what's going on. Please see 11, is the quiz due by a certain time? Yeah, the quiz is due by 12 tomorrow, before by noon time. Okay, so therefore give you a little bit more time to work on it until to upload to the website. But if you're okay with it, just go ahead and upload it to the website. Okay, one want to see number 11. Okay, let me see number 11 real quick. Okay, number 11. Oops, number 11. Okay, let me see 11. Let me see. Okay, share. Okay. Okay, so that's number 11. Okay. Stop sharing. Let me see what's the component. Okay, so the quiz for Tech 1 only, right, Sam? This is applied to everyone. All the quizzes for Tech 2, it is for you guys too. It's sort of review for you guys. So you want to do is keep on practicing doing this quiz because it does apply to you, because when I check, some of you guys are still failing the quiz, and so therefore you still don't understand the basic concept yet. So for Tech 2, yes, you go ahead and do this quiz and make sure you upload it into Tech 1 section. Do not upload it to Tech 2 section. Like I said before, the only thing, let me see, stop okay. So the only thing that you should be uploading to Tech 2, okay, this is only apply only for that you're going to be uploading to section 2. That is anything on the homework assignment that is coming exactly from Tech 2 assignments. That would go into section 2. Everything else, quizzes, which is cover the basic material, would go into section 1 or Tech 1. Okay, so when you upload, do not go in, just put in your first name, your last name, choose the file with the answer sheet that you need to upload, and then you click upload. That's it. Okay. But for the assignment, like I said, the only assignment that's from Tech 2 that need to be uploaded is only for this one right here. So if you completed this assignment, you will be needing to, for Tech 2 student, you're going to be putting your name here. Let's go make it clear. So my name here, I can go into choose my file. This would be a Tech 2 information, Tech 2. And then this is my Excel on my homework. So my first one, my homework number 1, click open. And as upload, it shows here. Now I want to put in section 2 folder. So therefore I click on this one and upload it. Now it's in my Tech 2 folder. Now I can retrieve, when I put a check mark here, I'm going to retrieve my folder from Tech 2. Okay, so now I see it right here. So this was what I just uploaded into Tech 2 folder for section 2 or Tech 2 student. Okay, so if I need to look at if I don't want to look at Tech 2, I just want to see the information in my Tech 1, I uncheck that and click on retrieve. And this was what I uploaded to my Tech 1 folder. Okay. So that's why I said, make sure that all these things that you're uploading for the quizzes, make sure you upload it to Tech section 1 or Tech 1, because it's a basic materials that that you guys need to cover. Okay, this quiz for Tech 1 only. No, it's for Tech 1 and Tech 2. We already answered that for Emily. Okay, so that's pretty much it. Okay, so thank you very much. So thank you for all the feedback and all the questions, so that way we'll make sure that we got everything clear. Okay.
Sam, I got one question about the homework.
Yeah, go ahead, Celso.
For the assignments, the newer assignments for labs 1 through 4, do we have to create the circuits in multi-sim and then do the assignments?
Yes, you need to create the MSIM summon. So we're gonna be something like, let me go share my screen. once more.
With the time, we'll be trying to continuing last time.
Yeah, Mr. Tai is going to cover the assignment from tomorrow, and then, so yeah, you're going through this some basic materials, how to, most of you should have this one downloaded, and then so Mr. Tai will be going over this tomorrow with you guys. So I will let Mr. reserve this for tomorrow, and then if you have question, you can bring it up tomorrow during Mr. Tai's lecture.
All right, thank you.
Yeah, so I don't have access to a laptop tonight. Can I upload it later? Yeah, like I said, this one due by noon tomorrow. Okay, so make sure to upload it. Okay, thank you. Okay, any other question? Okay, that's pretty much it. Thank you, Mr. Pham.
Thank you, Sam.
You're welcome.
Okay, so good night, everyone. See you guys next Monday.
Thank you, Mr. Pham.
Thank you, Mr.
Thank
Pham.
you.
Thank you.
Good night.